Hello students, now in this video let us see the types of skewness. So first one, let us see positive skewness. What is positive skewness? Now already we have seen the value of in non-symmetrical distribution, the skewness may be positive or negative, so it makes two parts of it. Fine. So let us see positive skewness. What does it? The asymmetric distribution which has asymmetric is same as to say not symmetric. Not symmetric or asymmetric are both the equivalent words. Okay. Asymmetric distribution which has first mean greater than median greater than what? Mode. Second property that Q3 minus Q2 is greater than Q2 minus Q1. Okay. Third, more density of observations in the lower part of the range of the variable than in the higher part of the variable. Okay. Then the next property is that the frequency increases rapidly to reach the maximum and further decreases slowly. The frequency increases rapidly to reach the maximum value, and further decreases slowly. Okay. Then next, the tail of the frequency curve is elongated towards right hand side, and the last one we can say mu3 is greater than 0. Mu3 is one of the moment, so that its value is what? Greater than 0. If these things are hold, then the distribution is said to have positive skewness. Now the examples of this one are the distribution of income of individuals house rent, then profits of companies, etc. These are what the basic examples or the well-known examples of this one. Now let me show how the graph of this one. Now the graph of this positive skewness is, it won't be a bell-shaped curve obviously. So the graph, as we say, the frequency distribution increases rapidly, and rather on decreases slowly. Here it will decrease as such. Fine. Now here the mean is greater, so here somewhere the mean, then this part, this is what, a median, this is a median, and somewhere here the mode lies, okay, sorry, I am right previously that the maximum number of, this is what, a mode, here obviously mean, and in between them here the median occurs. This is a median, okay, this is a mode, the highest one. A peak represents a mode. So this is what, a positively skewed distribution. That is skew, SK for skewness is what, greater than 0. Now this is a graph of it. Now let me show how does in box plot. We have already learned box plot in second chapter. So in box plot there is a range, x minimum, x maximum, and then we are finding quartiles, okay, and such a box we made there. So here suppose x minimum, here suppose x maximum, obviously, then this is q1, this is q3, and somewhere here q2 occurs. So q3 minus q2 is not same as q2 minus q1, and q3 minus q2 is more than q2 minus q1, it is greater. This is what, a positive skewness. This is a positive skewness. This is a box plot for that, a positive skewness, okay. Now let us see what is negative skewness. Negative skewness. Negative skewness. Now again let us see some of the properties of it. Those satisfied means it is a negative skewness. So the asymmetric distribution which has first mean less than median less than what, mode, means it is towards left, fine. Second thing, q3 minus q2 is less than q2 minus q1. Third thing, more density of observations in the upper part of the range of variable. of the range of variable. Next one, the tail of frequency curve is elongated towards left side. The next one, here mu3 is less than 0. Then it is said to be or said to have negative skewness. Okay. Now examples for this: the distribution of quantity supplied in commodity with respect to its price. First, can I say quantity supplied to or of a commodity means a committee or the society with respect to price. Okay, or we can say the number of depositors with respect to savings in a bank. Now let us see the graph and the box plot for this one also. Okay, so how does the graph of it? The graph of this one will be towards right. Here as such the graph of this. Here it will touch somewhere. Okay, so here this is what? A mode. Here somewhere a mean and a median is in between them. Here suppose what? The median. This is a median. Okay, now this is negatively skewed distribution. And the box plot for this one is again as x minimum, x maximum, here q1, q3 and here somewhere q2 are the median was there. So this is a box plot for negative skewness. You can verify the properties from this one also. Okay, now let us see the empirical relation. Already we have seen that empirical relation between mean, median and mode. So now you know that the mean minus mode is equal to what? 3 times mean minus what? Median. A relation between these three things, that are central measures of central tendency, that is mean, median and mode, that is the empirical relation between them. So for moderately skewed unimodal distribution, this empirical relation is given by Carl Pearson Holtz between the mean, mode and the median. Actually, in the moderately skewed part, here the equality doesn't hold, it is approximately equal to that one. It is not exactly equal, while it is approximately equal. This is empirical relation. I need to revise it as it is given by Carl Pearson. Empirical relation between mean, median and mode. And what? Mode. This one, and is given by Professor Carl Pearson. Carl Pearson for moderately skewed distribution. Moderately skewed distribution. Okay. Now let us see next part, that is measures of skewness. Now we have seen the skewness occur in some examples or in some distributions, and there are two parts of skewness, that are positive skewness and the negative skewness. So now let us see how does we can calculate them. So measures of skewness, as I said previously, there are two measures of skewness. First one, Carl Pearson coefficient of skewness, and the next one, Bowley's coefficient of skewness. So now this Carl Pearson coefficient of skewness is given by this Professor Carl Pearson. He is British biometrician and the statistician. Now it is also known as Pearsonian coefficient of skewness. It is a relative measure independent of units in which the variable are expressed, and is defined as the ratio of difference between mean and mode to the standard deviation of the distribution. Basically, it is a ratio. It is not depend on the unit, in which unit the data is given. It is independent of that one. The topic is measures of skewness. And first part in that, Carl Pearson's coefficient of skewness. In many researches it is used, so it is denoted by SKP. Okay, and it is also known as another name for it, what? Pearsonian coefficient of skewness. Pearsonian coefficient of skewness. It is given by, for your knowledge only, it is given by a British biometrician and statistician. Carl Pearson. Okay, fine. It is a relative measure. It is a relative measure independent of units in which the variables are expressed. Variables are expressed and is defined as the ratio of the difference between mean and mode to the standard deviation of the distribution. Okay, that is SKP is what? Mean minus mode upon standard deviation. Okay, or that is x bar minus mode upon sigma. Now here we will stop for today. In next video we will see some of the properties of it and the examples of this one. Okay, thank you.